Welcome to the first of the PowerPoint presentations around the maths topic we've got in 2012. This first topic looks at rules, equations and graphs. Things that we've looked at previously, although this time we're going to pay more attention to some calculations around the gradient, which is the slope of the line, and the y-intercept, which is where the graph, the line of the graph, crosses the y-axis. Before we start, I just want to point out that this should be seen as just a general overview or a general revision of the topics we've covered and not a comprehensive side of everything. For that, you're also going to need the notes that you take and the problems that you do in class and the textbook that you'll be given with the topic. So a good question to start with is, where would we use any of this in real life? So to give you a bit of an overview, let's consider a business where we can put together an example of a rule, an equation, and a graph. So think about someone starting a fishing charter business here in Bowden. The costs of the business might be $5,000 a year in the boat and licensing costs and $150 in fuel and bait every trip that they take. So we can put this together as a little bit of a rule. And we can say that the costs of the trip, the total costs for the year, are going to be $150 times the number of trips plus $5,000. That is, the total costs are going to be $150 being the fuel and bait for every trip plus the $5,000 a year in boat and licensing costs. We can even abbreviate that a little bit further and say, okay, well, let's make the C represent the costs and the T the number of trips. So our rule can be written as C equals 150T plus 5,000. And we can use this to show a little bit of maths jargon as well. Because we've got an equal sign here, this makes this an equation. One side is going to be equal to the other. Now we come down to looking and saying, okay, let's consider different numbers of trips. What's the cost going to be if I have no trips, 100 trips, and 200 trips? How can I calculate this? Well, if there are 0 trips, the cost is going to be 150 times 0, 150 times the number of trips, which is 0, plus $5,000. So the cost is going to be $5,000. If I have 100 trips, the cost is going to be 100 times 150, which is $15,000 plus the $5,000, $20,000. Similarly, the cost if there's 200 trips, 150 times 200 is $30,000 plus the $5,000 extra. So we now know the cost for different numbers of trips. And this is an example of the graph here. We can see at this point here that where we take 0 trips, the cost is $5,000 for the year. We can see that as the number of trips increases, the cost increases. For example, we calculated that for 200 trips, the cost was going to be 200 times $150, which is $30,000, plus the $5,000 of fixed cost, $35,000, which is this point here. We can also see that it's a straight line, which makes it a linear graph. So that's an example of putting together a rule, an equation, and some data to show the different costs for a fishing charter business depending on the number of trips taken in a year. There are a number of technical words or weasel words that we might have to understand. The first that we'll come across is a constant. A constant is a value in an equation that doesn't change. So for example, in the example where we said that the cost equals 150 times the number of trips plus $5,000, that $5,000 was a constant because it stayed the same regardless of how many trips were taken. A variable is something that changes. So the number of trips, T, could change in that equation. We could work out the cost for 100 trips or 500 trips or 1,000 trips. We then come to the y and x axes. These are the two sides of the graph. The x-axis runs along the bottom of the graph. The y-axis generally runs along the left-hand side of the graph. A linear graph or a linear equation just means it's one that represents a straight line. The y-intercept is the point where a graph crosses the y-axis. The gradient is the slope of the line, and to substitute means to put a number into an equation. For example, the equation we had was the cost equals 150 times t plus 5,000. Well, we could substitute in and say, what's 100 trips worth? We substitute 100 where we see the t, and we get 150 times 100, which is 15,000 plus 5,000 is 20,000. So there are some of the words we have to be familiar with. To have a look at this more thoroughly, let's consider the business of a plumber. She charges a call-out fee every time she has to go to a job of $60. So if you ring and ask for her to come and have a look at a problem, that costs $60 plus a fee of $100 an hour while she's working on the job. The question might be is, what is her total fee for different jobs? We can write this as a rule. We can say the total fee is going to be 100 times the number of hours she works, because her fee is $100 per hour, plus $60, which is the call-out fee that's charged in every situation. We can then abbreviate that a little and say, well, just using letters, F can stand for total fee, H the number of hours, F equals 100 times H plus 60. I want to draw your attention just to this little bit here. When we see something like 100H in maths, we have to remember that there is a times symbol between them. It's 100 multiplied by H. One of the ways maths works is we tend to drop that, but we do need to know if we see 100H or 4T, that means 4 times T, or 6W means 6 times W. We can now start to think about how we're going to graph this. We've got our rule, F equals 100H plus 60. Start to think about how we can put this on a graph. When we look at a graph, we usually talk about X and Y values. So what we can do here is say, okay, where we've got the total fee, we'll make that the Y value, and X will be the number of values. So now we can rewrite our rules saying, okay, Y, the total fee, Y equals 100X plus 60. We can say, okay, if X equals 1, the number of hours equals 1, 2, 3, or 4, we can do calculations of the total fee. So for example, for 1 hour, the total fee is going to be 100 times 1. $100 an hour times 1 hour plus $60 call-out fee is 160. And that's the calculation there. For X equals 2, it's going to be 100 times 2 plus 60. That's the calculation, $260 there. For 3 hours, we substitute 3 in where we see X. 100 times 3 is 300 plus 60 is 360, and the same for 460. So now we've got a table of values for X and Y. This is exactly the same table of values as in the last slide, and we can turn these into points. This is the first point here. For 1 hour work, the total fee is $160. So the point is, we write the X value first and the Y value second, 1, 160. The point here is 2, 260. The point here, 3, 360. And the point here is 4, 460. The last thing we've got to do is put these values on a graph. Remembering that good graphs have got titles, have got labels on the axes and units, we can say, okay, the first point we've got is the point 1, 160. The second point is the point 2, 260. 3, 360, and so on. And I've made a comment on the side there that this is a linear graph because it is a straight line. The next thing we've got once we've got our graph is that we can find the y-intercept, which is just where the graph, the line from the graph, crosses the y-axis. There are two ways that we can do this. The The first is that we can look at our graph and we can say, well, here's the point where the line crosses the y-axis and the value of x is 0, the value of y, the y-intercept is 60. So that's our first strategy. We can simply read off the graph that where x equals 0, y equals 60. Our second strategy is to use the rule we've got. So here, if we remember, is our rule. Y equals 100 times x plus 60. Now, we have to substitute in, and the line will cross the y-axis at the point where x equals 0. That's the y-axis. So we can substitute that in. 100 times 0, anything times 0 is 0. So 100 times 0 is 0, plus 60 gives you an answer of 60. Exactly the same as when we read off the graph. One of the maths rules is, or one of the maths traditions, is we often use the letter C for the y-intercept. So in this case, C equals 60. The next thing we have to do is be able to find the gradient, the slope of the line. If we know 2 points, we can find the gradient. There are different ways we can get the points. We might get the points from calculating them from the rule we've got. We might read 2 points off the graph. We might read them from a table of values. I've got a table of values here, so we can use these. The rule to find the gradient is this. It's y2 minus y1 divided by x2 minus x1. So let's have a look. That sounds a little bit complicated, but I think we'll be able to get to that and show how that works in practice. We need to start with 2 points. So the first point I've got here is just this point here. X equals 1, y equals 160. So that's point x1, y1 is 1, 160. The point x2, y2 is 4, 460. So they're the 2 points we've got. Going back to our rule, gradient is y2 minus y1 divided by x2 minus x1. So y2 is 460, so we can put that number in. y1 is 160. x2 is 4, x1 is 1. So here's our rule. y2 minus y1 divided by x2 minus x1. So it's 460 minus 160 divided by 4 minus 1. When we calculate those, 460 minus 160 is 300, divided by 3 is 100. We often use the letter m to stand for the gradient in maths. So in this case, m, the gradient, equals 100. The very last slide for this presentation is that we have what we call a standard form of the linear equation. Remembering a linear stands for a straight line of equation. And that is y equals mx plus c. Now this is different from other equations. For example, if you've got an x squared in there or an x cubed. This is just saying if you've got an equation in the form y equals mx plus c, we can work out some things. And those things are that m stands for the gradient and c is the y-intercept. Let's have a look at this equation here. Y equals 3x plus 50. If we look at that, we can see the gradient of this line is actually 3 and the y-intercept is 50. Thinking now about the example we used, we found that the gradient was 100 and the y-intercept was 60. So we know that we can write this in the form y equals 100x plus 60, which tells us that the gradient of this line is 100, the y-intercept is 60, and that gives us a form that tells us that information that we can use from there.